Hi everyone, my name's Adam Stevenson and I'm going to share with you today some of my experiences with containers and why I think they're an important tool for organisations who care about deploying applications. To start with, I've spent a lot of years in working with developers in consulting companies, and there's messages that I hear all the time. What developers want to do is they want to be able to create applications and they want to be able to do it without they feel like they get interfered with by IT. What they want to do is they really want to focus on building their applications. They want their new applications to run smoothly on their machines. They find that their new applications run smoothly on their machines, but when they then publish them out to the servers, they have a lot of issues, often regarded to server configuration or the dependencies that are installed. And they don't feel that they can be productive. They feel that their productivity and application innovation is suspended regularly because they have to wait on IT. Now, that's what the developers, they get very frustrated with the pace that IT works at. But then you go and you chat to the IT guys, and what we hear from the IT team is they think the developers are just a bunch of cowboys. What they focus on is they're focused on things like uptime. They need to manage servers and maintain compliance with as little disruption as possible. They find the developers giving them all these different applications, and a lot of them have different dependencies and underlying global dependencies that need to be installed on their servers. And they're unsure of how to integrate all of these different applications. And they need the developers to come and help them and explain how to get different things working on the same virtual machines. And they find they're unable to focus on both server protection and application compliance because they don't have a clear understanding of everything that's happening on their servers. So they're pretty frustrated by those cowboys who are just always constantly changing things. Now look, if you've been around IT teams and that are working with development teams, I'm sure this picture that I'm painting isn't a big stretch. But what is the answer? Well, we're here today to talk about containers, but the real answer is DevOps. But getting into DevOps requires a cultural change. And it's actually beyond the scope of today's conversation. What we're going to talk about is containers. And the nice thing about containers is I'm going to show you how they remove developer and IT, the friction between the development teams and the IT teams. I'm going to show you how containers reduce downtime, and really what containers are going to do is grease the wheels for DevOps. So what exactly is a container? Well, we're all familiar with traditional virtual machines. And what happens on a traditional virtual machine is there is a layer of hardware, there's a base operating system, and then we go and we create virtual machines that run on that operating system, on that hardware, and then we put the guest operating system in those virtual machines and then the applications we require. What happens with containers is that you still have hardware and you still have a host operating system. But then what we do is we go and we put each container that is then deployed onto that guest operating system is it required to contain the operating system itself. So essentially, what's in the containers is just the application and its dependencies, and we're going to see how that benefits us. So as I was saying, when we're talking about virtualization of our virtual machines, where there's a number of different ways we can do this. We've got hardware layers, hypervisors of virtual machines. Inside each virtual machine, there's a guest operating system, there's dependencies, and then there's an application, the application. When we talk about containerization, we only have, the key takeaway here is that we only have there's only one layer of host operating system. And that host operating system is shared by all of the containers. All the container contains is the application's dependencies and the application itself. Does that make sense? Look, there is, whenever you go and you look into a container presentation, there'll always be a variant of this slide, and they all irritate me. Who wants to have a guess at what irritates me about this slide? Have a bit of a think. What is wild? There is something on this slide that is wildly inaccurate. It's actually the scale. If you have a look, we've got the host operating systems, the application dependencies, and the applications all at about the same width. And it really does the containerization story a disservice. Let's have a look. So what I did, because it irritated me, I went through and I did my own version of that slide. And now what I've done is it's still not properly to scale, but it's much more correct. What we can see, this is very similar to the same slide. There's a hardware in the virtualization, there's a hypervisor, and on top of the hypervisor, we have each of our virtual machines. Now, each virtual machine has an operating system. So for Windows, that's about 16 gig. Then it'll have a layer of global dependencies, things like .NET if you're running .NET applications. It could be running Java, it could be whatever. It could be running Node, whatever your application runtime requires. And then on top of that, the little blue boxes is the applications. So really you see, when we've got a single virtual machine, we have those global dependencies and the applications installed, and our unit of scale is by virtual machine. So if you want to scale out and have more instances of those applications, what we need to do is spin up a whole new virtual machine, which means spinning up a whole nother 16 gig operating system, deploying on those global dependencies, and then deploying the applications on. If we have a look on the right-hand side, however, we can see I've done the containerization kind of to scale. So we've got the hardware, we've got the guest operating system on there. Now I've actually drawn that the same size as the Windows operating system, but this will usually be Linux, which is actually going to be much smaller than the 16 gig Windows system. On top of that, we've got the Docker engine, and then we've got all of those containers that only contain the application and the application's dependencies. Now, as you can see, we are getting much more bang for our buck with our containerization. We don't need to spin up the guest operating system when we want to scale out. When we want more instances of an application, we can actually just stick the container that has an instance of the container that has the applications and the dependencies into our Docker engine. So we're getting much higher density of our applications, a lot less wasted space. The other thing that comes of this is now that our unit of scale is the container, which is 200 or 300 meg instead of a 16 gig virtual machine, it actually is much faster to spin up. So there's, it consumes a lot less resources, it's a lot more dense, and your spin up time is a lot faster as well. So really, when we're talking about container advantages, we're talking about, with virtual machines, there's low utilization of of the resources. What we do is we move our applications into containers, and then we can use a lot less resources. And then we can deprovision the old virtual machines. Industry analysts agree by 2020, more than 50% of enterprises will run mission-critical containerized cloud-native apps in production. That's up from only 5% today. So look, when we're talking about containers, there's a bunch of real benefits. From the developer's point of view, they can iterate faster. They get agile delivery. So because they can iterate faster, they can now do agile delivery. The containers themselves are immutable. So every time you build one of those containers, you go and store it. And we'll talk about that a little bit in the next stage. And they can always go back to a previous build because those containers never change. From the IT department, they love it because they're getting cost saving, and they've now got efficient deployment. They don't need to worry about all of those dependencies that they used to have to install on the servers, because all the servers are contained in, all the dependencies are contained inside the containers. All they need to do is make sure they've got compute there to run containers, and they're going to be fine. They also love containers because it gives them elastic bursting, and we'll talk about that a little bit later. So let's have a little bit of a talk before we talk about the offerings that are available in Azure. Let's talk a little bit about what the container development workflow looks like. So we have a developer come along and they code their app. So it could be an NPM app, a Ruby app, a .NET Core app, and we're going to run with the .NET Core app sample. Now, we've got our code, we compile our code, but we want to turn that into a Docker. We want to go and we want to Dockerize our application. So the first step is we want a Docker file. And what a Docker file is it's really a recipe. And what it says is, it says, go and get me a base image. So there's libraries out there with base images, and there's base images for all of the different platforms that you can have. So what we're saying in this simple Docker file is go and get me the ASP.NET Core from Microsoft. Go and get me the ASP.NET Core image version 1.1. After that, we're going to change into the app working directory. We're going to copy, so we've got a compiled application. We're going to copy our compiled application into the app folder on our in our image, and then we're going to say that when this Docker file when this Docker image executes, it's going to go and run .NET, and it's going to run that ASP core .NET Core DLL. And that's the recipe. So we've compiled our code, and we've got this recipe that is going to execute to create our Docker image. So what we do is we go and create our image from that Docker file with the compiled application, and it does that by pulling down that ASP.NET Core original base image, putting our code on it, and specifying what the entry point is. Once we've got that, we go and create our own image now that's got our code compiled on top of that ASP.NET Core image, and we publish that out to our image library. There's a number of different image libraries you can use, but there's actually one provided with Azure, which is the Azure Container Registry, and that's where we go and stick our custom built images. So now we've actually updated our code, we've created a new image, we've pushed it to our library. What we can do is now run the container. Now, images and containers are terms that get mixed up a little bit. So essentially, it's like, for programmers, it's like a class and an instance of a class. The image is the blueprint, it's the blueprint that is sitting in the library. What we're able to do is, in our applications that are actually running on our servers, we go and get the image, and when we make instances of them, we call them running containers. So what we do is we go and get our image from the library, and we go and run that container. So we could run that in a number of different places. Here I'm saying it's running on a virtual machine, but that could be on my local desktop. It could be running in Azure. Then we go and we test it, and if we're happy with it, we then push it out into our other environment. So we could be pushing it out to a test server. If we're not happy with it after we've tested it, then we'll go and make some more code changes and go through that procedure again.